Hello everyone, this is Katrina Mendoza and I'm going to be a reporter for today. So we are now down to our third topic in this semester or in the preliminary term, wherein after the Y-bus admittance matrix, after our cron reduction method, is that our next topic, as you can see flash in our screen, is the LU factorization method, wherein our big concept for today is that certain matrices are easier to work with than others. In this section, we will see how to write any square matrix M as the product of two matrices that are easier to work with. So as you can see, we are now going to talk about our LU factorization method or the LU decomposition method, which is now flashing the screen, is that we are going to follow a roadmap to learning our LU factorization to enable each and every one of us to stand a chance in understanding step by step until we can solve a 4-8 LU factorization and of course of each type. Starting off with our definition and application of the LU factorization. Of course, we are not going to deal with solving our problems without knowing even the slightest definition or application where the LU factorization is used. Second is the types of LU factorization method, where we are now down to three types, wherein two types will be explained further by means of using different examples. The next would be the concept of each type of the LU method, wherein it is important for us to know what is the real deal when it comes to LU factorization, especially if we are going to dissect each part or each type of our LU method because they have different qualities, they have different processes, and it's important for us to know them. Our fourth one would be the process and solving the same given equation by means of using different types of the LU factorization. And of course, lastly would be the takeaway in this lesson because it is important for us to know or boil it all down to give a summary and bet that we would have enough or sufficient knowledge to be able to express and perform the LU factorization method. So starting off with our definition and application, following our roadmap, is that the LU decomposition or the LU factorization is also known to be as the LU decomposition of a matrix, which is known to be as a factorization of a given two matrix into two triangular matrices. One is the upper triangular matrix and one is the lower triangular matrix, such that the product of these two matrices gives the original matrix. So it was introduced by Alan Turing in 1948, who also created the Turing machine. So to just give an elaboration of our definition, we all know that in a certain matrix is that, for example, we have a 3 by 3 matrix. There is this what we call as the diagonal, right? So this diagonal coefficient and off-diagonal coefficient, the part where the diagonal coefficient separates the two components of the off and the upper off and the lower off diagonal is that is what we call the upper triangular matrix and the lower triangular matrix, because as you can see in our matrix is that there would be an upper matrix when we are going to diagonally dissect it and a lower triangular matrix if we are going to pull off the upper triangular matrix. So moving forward is that the LU decomposition method separates the time-consuming elimination of a matrix A from the manipulations of the right-hand side B. Thus, once A has been decomposed, multiple right-hand side vectors can be evaluated in an efficient manner. So if we are going to look back in our numerical analysis and method, is that we are going to see the analysis of both the Gaussian elimination, the Gaussian saddle, and different types of numerical methods, wherein one of those would be the LU decomposition. So in here is that we are just going to dissect it and decompose it. And the concept that we have to keep in mind or remind ourselves would be the upper and lower triangular parts of the matrix so that we will be guided accordingly. So now we are moving forward to the types of our LU factorization method. So as I've said a while ago or previously is that we have three LU factorization types. which is namely the Doolittle decomposition, the Krauts factorization, and the Cholesky method. These three methods will be given the meaning and definition, and of course, elaborated with its application. Wherein the first two, which is the Doolittle decomposition and the Krauts factorization, will be given enough emphasis by means of using equations and putting up matrices and performing the process. Wherein the last one, which is the Cholesky method, will only be given a definition and application because its performance requires only limited number of positive matrices, wherein we are not going to tackle as for today. So the Doolittle decomposition, it uses the idea of the LU factorization of a matrix A, where L have main diagonal equal to number 1. So as you can see flash in the screen are two matrices or 3 by 3 matrices, which is one is L and the other one is matrix U. And as you can see, we have the lower part of our triangular matrix in designated for matrix L and another upper part of our triangular matrix, which is designated to be as our matrix U. As for our Krauts matrix decomposition, is that in linear algebra, it is known to be as an LU decomposition, which decomposes a matrix into a lower triangular and an upper triangular, and although not always needed, is a permutation matrix that was developed by none other than the Prescott-Durand-Kraut. Actually, this is known to be as Kraut's matrix decomposition, but other sites would prefer it to be called Kraut only without the apostrophe S or not as a possessive noun. So the differences between the two is that the Kraut matrix decomposition is an algorithm that differs slightly from Doolittle. And Doolittle method returns a unit lower triangular matrix and an upper triangular matrix, while the Kraut method returns a lower matrix and a unit of an upper triangular matrix. So as you can see is that the Doolittle and the Kraut method is somehow reversed when it comes to the process. And as we are going to move on to our process later is that we are going to be given a clarification that even though the process would be similar, is that there would be chances that the lower matrix will be first solved, then the upper matrix, and the upper matrix on the other method will be solved first before it is moving forward to solving the lower triangular matrix. But in the end is that either Kraut or Doolittle is that we are going to arrive in the same values that is trying to be sought, which is the voltage as for the problem later. Now, as for our Cholesky decomposition, is that it is known to be as a powerful numerical optimization technique that is widely used in linear algebra. So it has this process of decomposing an Hermitian positive definite matrix into a lower triangular and its conjugate component. So this can be later used in optimally performing algebraic operations. As you can see, the reason why Cholesky decomposition is not going to be given an example for today is that its complexity and it just has too many complications and the values cannot be derived immediately as it requires limited number of matrices. Now, moving forward to our applications is that we have to take note that in general, the LU method of factorizing a matrix as a product of two triangular matrices has these various applications such as the solution of a system of equations, which itself is an integral part of many applications such as finding the current in the circuit and solution of discrete dynamical system problems, finding the inverse of a matrix, and finding the determinant of the matrix. So as for our example later is that we are going to solve for the voltage. So that would be the application of specifically the Doolittle and the Krauts method where in the end is that we are going to prove that either of the type of the LU, which is the Doolittle and the Krauts method, is that we are going to arrive with the same answer even though we had applied a different process. So it is not only enclosed to solving our current, but also yung ating discrete dynamical system problems and also yung inverse ng matrix natin. And of course, our basic determinant of the matrix. So as for the application, again, is that it comes in handy whenever it is possible to model the problem to be solved into matrix form. So we have to do this conversion to the matrix and solve the triangular matrices to make it easy to do calculations in the process of finding the solution. So there would be a lot of conversions, not literally the conversion of units, but the conversion of from an equation, we are going to create a 3 by 3 matrix. And from that 3 by 3 matrix is that we are going to dissect it into lower and upper triangular matrices, and then perform the equation, then solve for the values, then create another 3 by 3 matrix, and then solve for our v prime. Then after v prime is that we are then going to solve for finally our value to be sought, which is known as our voltage. So now moving to the concept of the LU factorization. And since alam na natin ang definition at kung saan siya ginagamit, is that we have to at least have an overview of what process is that we are going to undergo to be able to solve for either the Doolittle, the values by means of using the process of the Doolittle and our Kraut's method. So the concept is that to find the LU factorization in general is that, for example, we have a 2 by 2 matrix. As you can see dito sa baba, let me use my cursor. Dito sa baba is that this is what we call as the lower triangular matrix. And this is yung upper natin which has a value. Then another matrix here at the side is that we have the upper triangular matrix and this lower has a value. So as you can see, this is the original matrix, which is going to be turned in or converted to this type of matrix. So that's what I'm talking about earlier, that there would be a lot of conversions in the matrix to be able to arrive to the final answer. So as you can see, we have matrix A is equivalent to matrix L multiplied by our matrix letter U. So this A is matrix A, and this is known this matrix L is known to be as the lower triangular matrix. This U is known to be as the upper triangular matrix. Now, the Doolittle decomposition is known to be as of using the idea of the LU factorization, wherein the main diagonal is equal to number 1. Now, as you can see flash in the screen is that we have the L and the U matrices respectively, wherein in the previous slide, we had discussed that our L symbolizes our lower triangular matrix. As you can see here is that we have a 3 by 3 matrix, and this is known to be as our lower triangular matrix. And as for our U matrix, is known to be as the upper triangular matrix, and it is comprised of values, or this is the values to be sought, and these values would be given. So as for our Doolittle, once again, is that it has an algorithm wherein we have to start off with creating a linear equation in the matrix form of A, X, and B. Our A should be let LU, and L is known to be as the lower triangular matrix, and U is the upper triangular matrix. Those diagonal entries of L are equal to 1, which we are going to solve for L and U. So we have to let Ly be equal to B and solve for the values by letting Ux equals to Y. So as you can see is that by means of just reading it, is that it is complicated as it is only expressed in words and it is just an algorithm. But if we are going to undergo the process, the main process or the basic process, accordingly is that we are going to understand it fully as we are just going to move forward step by step and slowly so that each and every one of us could catch up. So as for the Kraut's matrix decomposition is that it is known to be as an alternative approach that involves our U matrix with ones on the diagonal. So this is what we call the Kraut decomposition matrix. The distinction between the two is that sa Kraut is that we are going to involve, of course, the upper triangular matrix wherein the ones would be on the diagonal. Dun sa kanina is that we don't have ones in our diagonal, but our upper triangular matrix are just comprised of variables. Those variables signifies the numbers to be sought or the values to be sought during the process. But as for our Kraut matrix decomposition is that you can see here that our L is that from the diagonal going to the lowest point of our matrix is that we are going to look for its values, and as for our U matrix is that we have ones on the diagonal side and the upper triangular will be the values to be sought. So Although there are some differences between the approaches, the performance is known to be comparable, as the Kraut decomposition approach generates the U and the L by sweeping through the matrix by columns and rows. And lastly would be the Cholesky method, wherein it is an LU decomposition that is limited only for symmetric positive matrix. So as you can see, flash on the screen is an example of the Cholesky method on how to arrange it in the form of a 3 by 3 matrix. So now we are moving forward to the process and example. So if we are going to start off, we are going to use the Doolittle decomposition, wherein, as I've said earlier, we are going to look for the values of voltage 1, 2, and 3, or the three voltages with the given equations, negative J2 plus J2.5 equals to 11 at an angle of 90 degrees. And our second equation would be J2.5 plus J4 plus J8, which is equivalent to 0. And our J5.5 minus J10 is equivalent to 0.8 and an angle of negative 120. So starting off with the process is that we have to input the values, these values into our matrix. So since we have three values with each equation, is that we are going to, of course, have a 3 by 3 matrix. So our negative 2, J25, and 0 would be given in the first base of our matrix. And next would be J2.5, J4, J8, and J5.50 and negative J10. So this accordingly is discussed in our Y-bus admittance matrix. So naturuan na tayo kung paano i-place ang ating values sa ating matrix. Just because ang first one would be is this line, the second would be this line, and this line would be the third one. And if it has no value, is that we are going to put a placeholder, which is 0. So it will be equivalent to another single matrix, wherein the will be equivalent to our equal sign, which is 11 at an angle of 90, a 0, and 0.8 at an angle of negative 120. As you can see, the second part is that we don't have any values, so it has been inputted with 0. So now flashing the screen is that what we had discussed previously on how to solve for our Doolittle, wherein we are going to start off with our lower multiplied by our upper and equivalent to the values given. So sabi natin dun sa ating Doolittle decomposition or Doolittle factorization is that yung ating lower triangular matrix ang may diagonal na 1. And this lower part would be the values to be sought, and this part would be the values given. So as for our upper is that this full diagonal up to the upper base of our matrix would be the values to be sought. So just meaning to say, ang pinag-iiba niya sa crowds is that baliktad sila. Now, the diagonal with ones would be given in the upper matrix, wherein the diagonal of the lower matrix or the lower triangular matrix up to the base would be the numbers or values to be sought. So moving forward is that, as you can see, this is what we had converted earlier. This is the first conversion that from equation, we have to put it in a 3 by 3 matrix and equivalent to our values over here. So this is yung summary lang ng ating Doolittle kung paano natin siya ilalagay sa susunod nating matrix, which is equivalent to this number. So moving forward to our next conversion is that, as you can see, papakita lang natin dito, i-flash lang natin sa screen so that may guide tayo sa mangyayaring kasunod. So now we are going to perform and solve for our values. Yung L21, 231, yung ating L32, yung ating U11, U12, U13, U22, U23, and our U33. So this is the values na kailangan nating mahanap. So basically, para mahanap yun is that we are going to use this matrix and this matrix as well and this matrix. So multiply lang tayo and just pure transposition or by multiplying the both sides by a number of something to come up with a certain value. Parang we are just looking for the value of x kung sa algebra. So the first thing is that our rows will be multiplied to our columns. Yung ating U11. Ang 1 natin is the same sa kabila ng U11. So, imumultiply natin sila sa isa't isa and it will be equivalent to negative J12. As you can see here, 1 times U11 or our U sub 11 will be equivalent to negative J2, wherein just by doing the math, anything that is multiplied by 1 would be equivalent to the other number. So U11 will be equivalent to negative J2. So we have the first value. Next one is that our 1 times U12. Why? Because yung ating 1, this 1 will be multiplied to this U12 since yung tapos na tayo dito sa part na to, itong part naman ng ating sasagutan. So 1 times U12 would be equivalent to our J2.5. So again, basically katulad lang ng una, is that anything that is multiplied by 1 would be equivalent to the other number. So our U12 would be equivalent to J2.5. So moving forward is that our solving for the value of L sub 21. So L sub 21 natin, nasa second row na tayo because this value 0 times U13 and another 0 will just come up with another value of 0 or will just result to 0. So, ang ating L21 will be multiplied to our U11 since nasa first row siya and equivalent to our J2.5. And ating yung U sub 11 natin will be equivalent to negative J2 since nasolve na natin siya kanina. So, by just doing the math is that we have to divide our J2.5 rather, to our negative J2. So, giving an answer, press your calculators, our L sub 21 will be equivalent to negative J 1.25. Next is that we are going to look for the value of U22. Ang U22 natin, para makuha siya, let's use our L21 once again. Multiplied by our U12, U12 plus our 1, itong 1 natin, times our U22. I hope na susundan kung paano natin nakuha yung equation. And of course, it will be equivalent to, after J2.5 is J4. So we will come up with a value of J 7.125. Next up is our U23. Ang U23 natin is pwede natin makuha, once again, since nasa second row tayo, we will make use of our L21. L21 will be multiplied by our U13. Since nandito na tayo sa pangatlo, di ba? Napansin nyo kanina na from L21, kapag solve natin yung U22, is that dito tayo mag-start. Imumultiply siya sa ating U12. Then, bababa siya dun sa ating pag-plus ng 1 at saka U22. Ngayon, if we are going to look for U23, we will make use of another L21 and our L21 will be multiplied dun sa taas ng U23 natin, which is U13. And of course, i-add natin from 1 times ating U23. I hope na-gets nyo. Parang, kung nasaan to, tapos ano yung value na hinahanap natin, dun siya imumultiply. Then, yung another katabi niya, imumultiply natin dun sa hinahanap. And it will be equivalent to our J8 since nasa second row ang ating hinahanap. Okay? So, by means of substituting the values na meron na tayo, ang L21 nga natin, sabi natin is negative J 1.25. Our U13, as a U13 natin, di ba sabi natin kanina kaya hindi na natin siya sinolve because 0 times U13 equivalent to 0 will just be equivalent or result to 0. So, that is why our U13 is our 0 over here. So, it will be add to 1 times U23 wherein by multiplying the numbers, that is, by just means of multiplying one to another number, we will come up to the other number as a result. So, it is equivalent to J8. Actually, that's J8, okay? Mali lang ng type dito. So, by means of doing the math, so we can arrive to an answer of negative J8 by means of transposing this, pero ang ating anything that is multiplied by 0 will be equivalent to 0. So, 0 na ito, kahit ilipat sa kabila, is that we will still have a value of J8. J8 over here minus a certain value, and we will come up with negative J8. Next is that our L31 times U11 is equivalent to J5.5. As you can see, nasa third row na tayo, and we are going to solve for our L31. L31 multiplied by our U11, since nandito siya sa first column, is that it will be equivalent to J55. And by just doing the math solely, is our L31, our U11 is equivalent to a value of negative J2. So, by means of dividing J 5.5 all over negative J2 is that we are coming up with an answer of negative 2.5 as for the values of L31. Now moving forward to our next value to be solved, which is L32. So as you can see here, our L31 will be multiplied to our U12 and will be added to the product of L32 and our U22. So mapapansin ninyo na always by means of using this lower diagonal matrix or this matrix is that lagi tayong pa-row or pa-horizontal. And if we are going to solve for something that's connected to this one is that we are going to follow the vertical path of the values. So as you can see here, it is now equivalent to 0 since solve natin L32. Kasi makikita mo na second siya, so equivalent siya sa 0. So as you can see, we are going to substitute the values na L31 natin will be equivalent to negative 2.75. U12 natin is J2.5. 132 natin yun yung hinahanap, U22 natin is J71.25, which is equivalent to 0. So by means of doing the math, is that we are going to arrive to an answer of 55 over 57. Okay, so now, we are going to solve for lastly the U33. Ang U33 natin is this one. So L31, make use of the L31 once again, and by means of multiplying it to U13, and i-add natin siya sa L32 and U23, and now basically 1 times U33. I hope na you get me yung pattern on how we are going to solve for a certain value because we are just parang nagsasalitan lang yung dalawang matrix na dito, yung sa baba. Tapos, since we are going to solve for U33, everything that is in this column is multiply dito sa row na ito. Since, kunyari, hinahanap natin U22, so everything in this row will be multiplied to this, everything in this column will be multiplied in this row. So basically, it is equivalent to negative J10. So now we are going to solve for U33. So multiply both sides with the value of this one. And we are going to come up with a value of negative J 1,010 all over 57. So as you can see is that na-solve na natin lahat yung values na hinahanap natin for the lower and our upper matrices. So L21, our L21 is this one, ang ating L31 is this one, our L32 is 55 over 57, our U11 is negative J2, our U12 is negative J2.5, and our what's next? U13 is equivalent to 0 yan. U22 natin is equivalent to J7.125. Yung atin namang U23, where's U23? U23 is equivalent to negative J8 and our U33 is equivalent to negative J 1010 all over 57. So after that is that we have to input the lower values in our matrix. So as you can see, lahat ng na-solve natin, di ba, pinakita ko sa inyo yung designations. So ipapalitan nyo lang yon nung values from the variable, magiging values na siya. So that's the reason why hinanap natin. Like for example, dito, di ba sabi natin sa lower matrix kapag if we are performing the Doolittle is that all of the diagonals will be equivalent to 1. So, meaning ito is known as our L21. Let's look for the value of L21 previously. L21 is equivalent to, as you can see here, is negative J1.25. And you can see here is that ang ating L21 is equivalent to negative 1.25. So, lahat lang ng values na kailangan natin, which is L31 and L32, is substitute natin based dun sa nakuha natin kanina and multiplied by V, our voltage prime, equivalent to these values na nakaset natin kanina from our equation. So after that is that we are now going to solve for V1 prime, V2 prime, and our V3 prime. So our V1 prime, once again, is multiplied by 1, ito yung V prime, and equivalent to 1.1 at an angle of 90 degrees. So basically, everything that is multiplied by 1 will be equivalent to the other number. And now we have V1 prime equivalent to 1.1 at an angle of 90 degrees. Next stop is we are going to solve for our V2 prime. So we always have to remember kunwari nakapag-solve na tayo ng isang value is that we are just going to substitute it kapag nag-appear sa second equation natin, wherein now we are going to solve for V2 prime. So again, our negative 1.25 multiplied by our V1 prime plus our V2 prime is equivalent to 0, of course. So ang V1 prime natin is 1.1 at an angle of 90, substitute it, and now multiplying this 2, and then multiplying this 2 and lilipat natin dito sa kanila or multiply both sides by the answer of this product is that we are going to arrive at an answer of 1.375 at an angle of 90 degrees. Next step is that we are going to look for the values of the V3 prime. So medyo mahaba yung solution niya dito, pero just take note that we are just multiplying our rows to columns and equivalent to the other matrix para dun sa equal natin dun sa other side of our equation. So, negative 2.75 multiplied by V1 prime, ipa-plus naman natin sa 55 over 57 times V2 prime, and our plus V3 prime. Then, it will be equivalent, of course, to 0.8 at an angle of negative 120. V1 and V2 has its value, substitute it, and now performing the equation is that kunin mo yung product nito, pag-add mo silang dalawa, what do you call this? Divide both sides by the value of this 2. And now we are going to arrive to an answer of 1.0821 at an angle of 111.6947 degrees. The moment na dinivide natin itong 0.8 at angle of 120 to the sum of these two terms. Okay? So, ibig sabihin, ang V1 prime natin is 1.1. At an angle of 90, ang V2 prime natin is 1.375 at an angle of 90 degrees, and our V3 prime is 1.0821 at an angle of 111.6947 degrees. Okay, since tapos na tayo mag-input ng lower values sa matrix natin and we had solved for the V1 prime, V2 prime, and V3 prime, is that we are going to solve for our three values of voltages. So dito kasi we have to input the upper values in the matrix. That's a typo. So we have to input our upper values in the matrix sa nakuha natin sa pinakauna pa. And sabi nga natin, di ba, there are no diagonal ones if we are going to solve for our or if we are going to input values sa ating upper triangular matrix. So simply put, yung ating U12 is negative J2. And yung so on and so forth is that we are just going to substitute it. Basta everything that we had solved for the values earlier, yung upper matrix doon, U12, U22, U23, and U22, U23, and our U33 is that yung sagot doon is we are just going to substitute it in our matrix, 3 by 3 matrix over here. So again, we are now going to multiply it with our matrix of V1, V2, and V3, and equivalent dun sa ating 1.1 90 degrees, yung nakuha nating mga values kanina. As you can see, yung mga V prime natin. Yan, V1 prime, V2 prime, and V3 prime, igagawin natin, i-equate natin or equal siya doon sa ating upper values multiplied by our V. And now we are going to solve for our V3. So basically, since 0, 0 to, kahit 0 V1 mo or 0 V2 is that it is just equivalent to 0. So now we are going to just multiply negative J 1010 over 57 to our V3 and it will be equivalent to this value. So as you can see, V3 po ito, it's just that it's a typo. So yung V3, to solve for V3 is that our 1.0821 at an angle of 111.6947 would be divided to negative J 1010 all over 57. And it will arrive to an answer of our voltage 3, which is 0.0611 at an angle of negative 158.3053 degrees voltage. So now we have the value of our V3, meaning to say is that pwede natin siyang gamitin later so that we could arrive to an answer of V2 and V1 by means of substituting its value. So now we are going to solve for our V2. It is just the same matrix. Pina-flash ko lang siya sa screen so that everyone would be guided. So our V2, okay, V2 natin is in this line. This line, okay? So our V2 will be multiplied to our J7 1.25. But hindi na sinama yung V1 because 0 times V1 is just basically 0. So, kahit i-plus mo siya dun sa other amounts natin or other values is that wala siyang magiging effect. So, magsistart na agad tayo sa V2 times J7.125 and it will be added, of course, to our value J8 times V3. So, it is equivalent or equated to our 1.375 at an angle of 90 degrees. So, ang mangyayari is that our V3 has a value. Substitute that value over here and now perform the operation. So basically, plus sign to, lipat natin sa kabila or just by, lipat natin sa kabila or subtract both sides with J8 times 0.0611 at an angle of negative 158.3053 degrees. Then after that, after getting the difference is that we have to divide it by J 7.125 and press your calculator. So we'll arrive at an answer of V2 equals 0.2579 at an angle of 5.6393 degrees voltage. So now we have the value of our second voltage. Now we are solving for our V1. So V1 natin is nasa first row. So everything here will be multiplied to our column. So our negative J2 multiplied to V1 plus our J 2.5 multiplied to V2. Kahit i-plus mo ito, 0 times V3, walang magiging effect. That's the reason why 0 dito, and it will be equated or equal to 1.1 at an angle of 90 degrees. And after that, is that substitute yung V2, and we will perform the operation and solve for V1. As you can see, is 1.1 at an angle of 90 degrees minus negative J 2.5 times 0.2579 at an angle of 5.6393 all over our J2. So our V1 will be equivalent to 0.2313 at an angle of 172.1274 degrees voltage. So as you can see is that ito yung tatlo nating voltage. We have to keep in mind or list down na natin ngayon. Ang V3 natin is this one. Ang V2 natin is this one. Ang V1 natin is this value. Because later, we are now going to use the Kraut's method to be able to solve for the same equation. And let's see if we are going to arrive to the same values of our voltage 1, 2, and 3. So now moving forward to our crowd decomposition method is that we are still now going to find for V1, V2, and V3. So given the equations once again, is that it is the same set of equations that is given in our Doolittle decomposition method. So our process for this Kraut's decomposition method is that step 1, A is equivalent to LU. Our step 2 is B is equivalent to LY. And our step 3 is UX equivalent to Y. So ito yung kailangan nating sundan na steps to be able to arrive to an answer at para hindi tayo mawala. So that may pattern tayo kung anong dapat nating sundan. It's just the same as our Doolittle kasi sa Doolittle natin may steps din. It's just not elaborated in this way, pero it's just the same process na parang from conversion of one matrix to conversion of another matrix is that may maukuha tayong values until maka-arrive tayo sa ating hinahanap na V1, V2, and V3. So as you can see, A natin is just the 3x3 matrix na sinet from our given equation. Our B, ang B natin is yung equivalent natin. Dun, as you can see here, pakita ko sa inyo ulit. So this is doon sa ating left side na before yung equal sign is that yun yung ating set A or matrix A. Doon sa kabilang side, that is our matrix B. So as you can see here, elaborately ganyan siya. And our X is yung V1, V2, V3 natin. And yung Y is V1 prime, V2 prime, and V3 prime. So what is this A, B, X, and Y? As you can see, sabi natin dito, ang step 1 natin ay comprised ng A equals LU. Basically, LU is the lower triangular and upper triangular. B natin is this one. And L natin is yung lower. Yung Y natin is this one. Yung U natin is yung upper, X natin is this one, and Y natin, once again, is this V prime. So, mapapansin ninyo is that parang ito din yung process na ginawa natin kanina sa Doolittle. The only difference is that nasa upper yung ating 1 sa diagonal part. So now, moving forward with our first step, which is A equals to LU. So basically, yung value ng A natin, as you can see kanina, is yun yung mga nilagay natin from the given set of equations to a matrix, 3x3 matrix. So our LU is the lower and upper. So matatandaan natin sa Doolittle is that ang ating lower yun yung may 1 sa diagonal, but here we are going to use the 1's diagonal doon sa ating upper. So same goes sa process na ginawa natin sa Doolittle is that at least mas gets na natin sa this part, okay? Kasi na-discuss na natin yung pag-arrange and all sorts of method and conversion from given equation to matrix and matrix to another matrix by means of after looking for every value is that makukuha na natin yung result. So now flashing the screen is our A. This is our matrix A, this is our matrix L, and this is our matrix U. And as promised and as I've stated earlier, our was is nasa upper diagonal or upper triangular matrix. So as you can see, we are just going to perform the operation and look for the values of L12, L21, L22, L31, L32, and L33, U12, U13, and U23. Now we are going to solve for our L11 and I just have a clarification. Ang L11 natin is this part, this L12 and this L13 supposedly. Pero this is just a typo, so this L11. So sabi natin to be able to come up with the values is that we have to multiply the rows times column. So our L11, as you can see, ang pinagkaiba lang niya is that naka-equate kanina yung doolittle dun sa kabila and ito naka-equate dito sa kabila. So, it's just the same. Is that magpapalit lang sila ng pwesto. So, our L11 will be multiplied to our 1 and equate given to our negative J2. So, negative J2 equals to our L11 times 1. Basically, our L11 will be equivalent to negative J2. So, ang next value na isosolve natin is U12. Itong U12 natin, as you can see, kapag parang i-reflect natin dun sa kabilang matrix dun sa left side before our equal sign, is that it is J2.5. So, yun yung gagamitin natin. So, our J2.5 will be equivalent to L11 since nasa isang row sila multiplied by our U12 and our U12 will be added to 0 times U13, which is equivalent to 0, kaya 0 to. And now we are just going to perform the operation, J2.5 and negative J2. Since ang U11 natin, it has a value of negative J2 times our U12. So, ang ating J2.5 divided by negative J2, it will be equated and given the answer of U12 equivalent to negative J1.25. Next stop, our next value. So, ang hahanapin natin is U13. So, U13 nandito sa ating row na to. So, ating L11 will be multiplied to our U13, which is equivalent to 0 since 0 yung value na katapat ng ating U13. So, U13 is basically equivalent to 0. Since our L11, substitute natin negative J2, hindi ko na lang siya nalagay dito, pero nevertheless, is that 0 all over a number is still equivalent to 0. That's why our U13 is equivalent to the value of 0. Next stop. Our J2.5 equals L21 times 1, wherein we are going to solve for the value of L21. So, this is the row of our L21. And sabi nga natin, nagre-reflect ito sa kabilang matrix, which is J2.5. Kaya J2.5 to equivalent to L21 times our 1. So, it is equivalent to our value na J2.5. Now, to solve for our L22. So, basically, ito yung L22 natin. Reflect sa kabila. This is J4. J4 will be equivalent to L21 times our U12. Tapos, plus sa L22 natin times ang ating value na 1. So, just by means of doing the math, substitute natin L21, ang U12. Since may values na tayo, anything multiplied by 1 is given an answer that is equivalent to the other value. And now, we are just basically going to solve for the product of this and subtract it with J4, and what L22 will be equivalent to J7.125. And lastly, let's solve for our U23. So, ang U23 natin is here. U23 reflect sa kabila is equivalent to J8, and our J8 will be equivalent to L21, and L21 multiplied by U13. And plus our L22 times our U23. So, substitute yung may mga values na. L21 is J2.5, U13 is 0, and L22 is J7.125. And still, ang U23 yung value na hinahanap natin. So, just equate, now solving for the equation is that U23 will be equivalent to 64 all over 57. And I hope everyone is catching up and pressing their calculator for confirmation. So, now we are going to solve for L31. L31 natin will be equivalent to L31 times the value of 1, i-reflect sa kabila is J5.5. So, that's why J5.5 equivalent to L31 times our 1 and equivalent to still J5.5. Next is our L32. Second to the last is that we are going to solve for the value of it. So L31 times our U12, since nasa second to, right? So our L32 rather times our value of 1 and at L33 times 0. So hindi na lang nilagay but that's plus 0. So hindi naman siya magbabago. And now we are just going to substitute the values. L31 is equivalent to J5.5, U12 is negative 1.25, and our L32 is the value to be solved. So by means of solving the equation, L32 is equivalent to J 6.875. And lastly, let us look for the values of L33. So our L33 is in this row, so reflect sa kabila, that's negative J10. Negative J10, L31 times our U13, and plus our L32 times U33. That's U23 actually, U23 to. Times U23 plus our L33. So by means of substituting it, L31 is 0, U13 is J6.875, and times 64 all over 57 plus our L33. So L33 is equivalent to negative J 1010 all over 57, which is a familiar number na nasolve natin doon sa latter part na method. Now, we are now down to our second step, which is B is equivalent to Ly. So meaning to say another conversion of matrix. So as you can see, we have to input the values nung ating lower matrix, lower triangular matrix. So everything nakuha nating L12, 2, 1, 3, 1, 2, 2, 3, 2, and 3, 3, substitute lang natin yung lahat from the values na nakuha natin kanina. It will be equivalent to this matrix. Now, we are just going to convert it once again to this step dito sa formula na to, wherein dito is that Ly equivalent to B. Ang L natin is yung lower matrix or lower triangular matrix. That is why ito yung value natin. Yung Y natin would be the V1 prime, V2 prime, and V3 prime, which is equivalent dun sa B natin, which is the answers from our given equation or doon sa na-equate sa kabila. Okay, now we are going to solve for our value. So, ito na yung bago nating matrix since na-apply na natin yung Ly is equivalent to B. So, we are going to solve for V1 prime, V2 prime, and V3 prime. So, our V1 prime basically is that negative J2, as in negative J2 natin, starting off with this one, negative J2 multiplied by our V1 prime kasi ang ating 0 times V2 and 0 times V3 prime is equivalent to 0. So, hindi na siya inequate dito. And reflecting to our rows that is equivalent to the other matrix of V1 natin is 1.1 at an angle of 90 degrees. So by means of solving for this equation is that we have to divide 1.1 at an angle of 90 degrees to negative J2. So our V1 prime will be equivalent to negative 11 all over 20. Next stop, solving for our V2 prime. Ang V2 prime natin is masosolve by means of multiplying ang V1 prime times J2.5 plus J7.125 times V2 prime equivalent to our 0. So, ang V1 natin has a value of negative 11 all over 20. So, meaning to say, solving for the equations that ililipat natin to sa kabila and i-divide natin yung value na yon from J 7.125. So, our V2 prime will be equivalent to 11 all over 57. And lastly, for our V3 prime, same process lang sa Doolittle's and I hope hindi kayo nalilito is that our J 5.5 multiplied by our V1 prime and our J plus our J 6.875 times V2 prime and our negative J 1010 over 57 times our V3 and equivalent dito sa value natin ito. And substitute natin ang V1 and V2. And solving for this equation, press your calculators for confirmation. Our V3 prime is equivalent to 0.0611 at an angle of negative 158.30, 53 degrees. Now moving forward to our third step. Our third step is Ux equivalent to Y. So basically, our upper matrix will be multiplied dun sa X na pinakita natin kanina. And all of the values from the upper matrix na nakuha natin sa values in our first step will be substituted here. So diagonal natin will be comprised of 1, all 1, and our U12 is negative 1.25, U13 is 0, and our U23 is 64 all over 57. So by means of converting it to another matrix is that our Ux or upper matrix, which is this one, yung nakuha natin from substituting, is multiplied our X. Sabi natin kanina, X natin is V1, V2, and V3 matrix. And our Y would be equivalent dun sa na-solve nating primes, voltage primes kanina. So, okay. Now we are going to solve for the values of 1, 2, 3 voltage. So by means of using this equation or this matrix rather is that we're going to solve for V3 first. Same process din sa Doolittle. So our 1, V3 ano? Ito yung V3 row natin. So 0, 0, so meaning to say 0 times V1, 0 times V2, hindi magmamatter. So diretso na tayo sa 1 times V3. Equivalent dun sa ating kabila which is 0.0611 at an angle of negative 158.3053 degrees. So basically, by means of solving for the equation, our V3 would be equivalent to the same value which is 0.0611 at an angle of negative 158.3053 degrees voltage. Next one is that we're going to solve for the second voltage. And so far, our V3 is equivalent to the V3 that is solved in our Doolittle. So, kung na-jot down ninyo yung ating V3 sa Doolittle, makikita ninyo is they are the same. So, next, I hope all the way until V1 is that same sila. Solving for V2 is that our V2 plus 64 all over 57 times V3 since 1 times V2, kasi ang 0 times V1 is 0, so dumiretso na tayong 1 times V2 plus 64, 57 times V3, and since ang nag-reflect sa kabila is 11 over 57, doon siya naka-equate. So basically, by means of substituting V3, ilalagay natin dito yung value, i-multiply sa 64 all over 57, and i-minus natin from 11 all over 57, ang V2 natin has a value of 0.2579 at an angle of 5.6393 degrees voltage. And lastly, we are going to solve for our voltage 1. And mas madali na siya since may values na tayo ng V2 or V3. Pero here, we are just going to make use of our V2 since ang ating V3 is mapapatapat sa multiply with a 0. So 0 na agad siya. So, hindi na natin siya isasama. So, our V1 times 1 plus our negative 1.25 times V2. And it will be equivalent doon sa nag-reflect sa kabila along the row of V1 which is negative 11 all over 20. So, solving for the equation, substitute our V2. And our V1 will now be equivalent to 0.2313 at an angle of 172.1274 at degrees voltage. So, wag natin kakalimutan yung unit of voltage since we are going to be wrong with our answer. It will be inaccurate. So as you can see, the voltages na nahanap natin sa Krauts will be equivalent din dun sa nahanap natin kanina sa Doolittle. So no matter what process ang gamitin natin, either Doolittle and Krauts, is that we are just going to arrive with the same answer as long as, of course, we had used the same set of values and we had followed the process properly. So maalin doon sa dalawa is that for me, they just have the same length of process. Walang mas madali, walang mas mahirap because basically pinagpalit lang naman kung nasaan yung values ng 1 sa diagonal, either lower or sa upper, and that is the basic distinction between the Krauts and the Doolittle decomposition. And now lastly, we are moving forward to our takeaway. I therefore conclude that basically the LE decomposition method comes in handy whenever it is possible to model the problem to be solved into a matrix form. So sabi nga natin paulit-ulit that there will be numerous of conversions to the matrix form, and solving with the triangular matrices makes it easy to do so, the calculations in the process of finding the solutions. So basically, there are a lot of conversions that had happened dun sa either Doolittle at Krauts method natin. So sabi nga natin, there were a triangular matrices na either nasaan yung 1 ba nun, nasa upper or nasa lower ng diagonal. Yun yung nagdi-differ or nagiging distinction. Whether it is Krauts or Doolittle, so mas mapapadali yung process natin if we are following the processes, following the steps to be undertaken in each method. So next up, our LU decomposition is better way to implement Gauss elimination, especially for repeated solving in number of equations with the same left-hand side. So sabi natin always, everything is compared to the Gauss elimination because it is somehow complicated and sobrang haba and lengthy ng process niya. So by means of using, again, the LU decomposition is that it is a better way to implement the Gauss elimination, especially kapag same left-hand side naman yung equations na gagamitin. So our other conclusion is that there are three methods ng LU factorization, which is the Doolittle, Kraut, and the Cholesky, and from which first two is performed to have a lengthy manual calculation, and the Cholesky decomposition weren't able to be performed due to limited matrices. But what should be present in the diagonal of the L and the U matrix is given by the Doolittle and Kraut scheme. Without the Doolittle and Kraut scheme, it is very difficult to determine the entries of our L and U matrix. So basically, from our first-hand experience doon sa process is that by means of identifying our lower triangle and our upper triangle matrices, is that mabilis nating na-solve ang voltages natin or kung ano man yung value na nais natin hanapin because we had a first-hand we had basically inputted all the values from the equation to a matrix and then eventually from the lower and upper matrix. And by means of substituting it and solving for the values in that certain matrix. And now we are going to solve for the V prime and finally our voltage. And now comes the end of our journey in discussing the LU factorization. The LU factorization, we have to keep in mind or be reminded that it has three categories, the Doolittle, the Krauts, and of course the Cholesky, where the Cholesky haven't been discussed because of its limited matrices and its complicated process wherein it would be lengthy than the other two. So it is better yet that any other or so it's better yet na yung dalawa na lang yung sinolve natin and our Kraut and Doolittle either processes would be enough for us to arrive to an answer wherein parehas lang yung length nila for my evaluation. But in the end is that if you are given the same set of equations, if you're going to perform it in both, is that you are just going to arrive with the same answer. So that is all for today, guys. Thank you so much for listening. If you have any questions, is that you can find me at Katrina and Mendoza at slsu.edu.ph. And I just wanted to remind all of you that to stay positive and always look at the bright side. Again, this is Katrina Mendoza, your reporter for today, and see you in the next episode. Bye, guys.